Hey guys, welcome back to the channel. Today we're going to be talking about whether protein can cause obesity in children or not. It is in the best interest of her babies if a mother can prepare her unborn children for the environment that they will be entering when they're born. If a pregnant cricket is exposed to wolf spiders, later her offspring will act more defensively when they see a wolf spider compared to cricket offspring who never saw wolf spiders. Somehow, the mother cricket alerted her unborn offspring to the presence of wolf spiders in the environment so they can come into the world more prepared. This is a great adaptive ability that prepares the offspring for the specific environment that they're going to be born into. The same thing happens in plants. Plants with the same genetics were split into two groups, with one group being exposed to sunlight and the other group to shade. Those exposed to sunlight produced seeds that grew better in sunlight, and those exposed to shade produced seeds that grew better in shade. These were genetically identical plants, so this was not caused by a difference in their genes, but by epigenetics. Epi means above. These are changes that are happening on top of the inherited genetics and can alter how the genes are expressed to better suit their actual and specific environment. Voles are small mouse-like rodents. The mothers of those born in the cold season are able to communicate to their pups that the weather is cold, so they are born with a thicker coat of fur. The same can be seen in people. We've noticed that some people are cold all the time while others can tolerate cold weather without difficulty. Depending on the average temperature of the environment you're born into, you'll develop different numbers of sweat glands to optimize your ability to handle the climate you're born into. Can diet also affect your epigenome? During World War II, the Dutch were deprived of food by the Nazis. This caused the Dutch famine. Children born during this time had a significantly higher chance of being obese 50 years later. While their mothers were pregnant with them, they were epigenetically prepared for a world where food would be hard to find. They were born with bodies programmed to conserve calories as much as possible. But while the famine ended after the war, their epigenetic programming did not. Their programming to hold on to every calorie was now no longer a benefit and led to obesity and the diseases associated with obesity. What a mother eats during pregnancy not only affects the weight of the baby, but the adult weight as well. Another example shows that the amount of protein eaten by a pregnant woman can affect the weight of her children 20 years later. This was not just any protein. It was primarily associated with the intake of meat products and had a somewhat stronger effect on daughters. Every extra portion of meat eaten by the mother during the last trimester of pregnancy led to an increase in likelihood of increased body fat by the child's 16th birthday. This increases the risk that this child will become an obese adult and is independent of the number of calories they ate or how much they exercise. What is the potential cause of this weight gain? It is believed to be related to chemicals in our environment called obesogens, or chemicals that cause obesity. Not only are adults heavier, but so are infants and pets and lab animals and even rats in the subway. This all can be blamed on poor diet and lack of exercise. 8 different species were studied, and all had similar increases in obesity. The likely culprits are obesogens. These can be found in cigarette smoke, car exhaust, and in grilled or charred meat. The more children are exposed to these chemicals, the more obese they tend to be. If children are exposed to these chemicals when their mother is pregnant with them, they have a higher risk of childhood obesity. The exposure to these chemicals can be measured in the urine of these mothers and children. As a side note, these same chemicals have been shown to increase the risk of breast cancer in women. So, for the average person, where do these chemicals come from? For those who smoke, half comes from cigarettes and half from their food. For those who don't smoke, almost all of it comes from their food. The highest levels of these chemicals are found in meat, with pork having more than beef. Anything that is grown near a highway can be contaminated by the exhaust of cars and trucks traveling on that highway, so make sure to wash your produce well. These chemicals tend to dissolve better in fat, so fatty foods tend to be more contaminated. Plant products tend to have less fat and hold less of these chemicals than meat, unless a lot of oil is added to the plant-based foods, which can then dissolve and carry the chemicals into our bodies. Luckily, our bodies can clear out these chemicals regularly. After eating grilled chicken, the levels of these chemicals spike by 100 times, but after about 20 hours, the body is able to clear the chemicals. The problem is that people eat these contaminated foods on a regular basis and don't allow them to be cleared by the body. Keeping meat intake to a minimum and favoring plant-based foods can lower the levels of these chemicals in our bodies and lower the risk of obesity and diseases related to these chemicals. This can not only affect the health of adults, but also their children and even their grandchildren. The epigenetic effect has been shown to carry these unhealthy lifestyle choices to future generations and may explain the explosion in the rates of obesity and disease as the Western lifestyle is adopted by more people around the globe. Anyways, thanks for watching. Be sure to like, subscribe, and comment down below what you guys want to see next. Thank you.